So today we're going to talk about the identiPol, which is a very compact thermal analysis device that enables you to do extremely good quality control of plastic material. And the principal modes it has are an identification mode, where we can actually check what type of plastic we have, material confirmation, where it checks that the delivery of material is going to be the same as we've used before, and then the comparison, where we can check one grade of material against another. This is very useful, for example, for checking recyclate material that's meant to be the same grade, just to see how close it is. And finally, as an optional extra, we can give you an indication of the melt flow index for polypropylene and polyethylene. First of all, then, the identification of an amorphous material. This is polycarbonate. Here we can see the answers for polycarbonate, a glass transition of 158 degrees C. Oh, excuse me. And these are all automatically measured. There is no melting point because there's no crystalline material, because it's amorphous, and an end point of 166.3. I'll describe what the end point is in a minute. So here it's measured the melting point. There is no melting point, and it's measured the end point. So here's a similar answer for a semi-crystalline material, this time polypropylene. We've measured the melting point. We couldn't measure the TG because that's below room temperature, and we didn't start this test below room temperature. There's an end point measured of 155.7. Here you can see it's polypropylene, and we've identified it as semi-crystalline. There's insufficient data to measure TG because it's below room temperature. It's matched the melting point, and it's matched the end points. If we go on now to see how these materials are identified, there are three principal properties measured by the identiPol, and they are the dynamic storage stiffness. This is like a storage modulus. Tan delta, which is the damping behavior of the material. These two parameters are normally measured in a DMA, a dynamic mechanical analysis machine. And then finally, we get a delta T trace, which is like the data we observe in a DSC, and we use this for finding a melting peak. And here's an example of all those three traces. So here we have how the stiffness falls with the increasing temperature. This is the delta T signal, and this is the tan delta information here, the damping material, the damping properties of the material. And because it's amorphous, there's no melting peak, so there's nothing to see in this data trace here. You can see how the stiffness drops dramatically with temperature as the material softens, and where this red line comes, this is the end point. And you'll see shortly the material is actually held in a metal sample holder. It's moulded into that sample holder within the identiPol instrument, and where we can no longer differentiate between the plastic and the empty holder, that defines the endpoint. And these little boxes with the names of the polymers on, these are the range of endpoints that we use to identify these materials. Similarly, these are the range of melting points, and these are the ranges of glass transition. So if we move on, here's the result for a semi-crystalline material. Here you can see the fall off in stiffness again. And at this point, it could be, you can see here, it could be polypropylene, it could be PMMA. But because PMMA is amorphous, the PP has a melting point, which is clearly identified here. So this material must be PP and not PMA. And here you see the tan delta trace for this material. The tan delta gives us a very good fingerprint for the material, and we use this to do the comparison between the incoming batches and when we compare the grades. There's a further identification we can make. Once we've actually set up reference sets for the grades of material that we're using in the factory, we can ask the identiPol, can you match the result we've just measured to one of the existing grades that we have in our database? And so here, it's actually found that it's polypropylene again, but we've told it to match the grades. And if I go to the next slide, what you see here, this is based on a customer's data. They have 6 different grades of polypropylene that they use in their factory. And these grades are represented down here. And you can see the test we have here, number 232, it's actually compared against all 6 grades of polypropylene. And in fact, it scores 0 with all of them, except for the material it is. This is actually this HL512 material. So this is an incredibly useful feature, because if you use some kind of spectroscopic technique such as FTIR, all of these polypropylenes would appear to be very, very similar. And the identiPol, because it can match the thermomechanical properties, it's quite easy to match the properties of the grade you've got to the other grades within your reference set. And this is extremely useful if there's a mix-up between which material you have. It's a simple 15-minute test will tell you which material it is. Now, the confirmation, which is the main quality assurance mode, we rely on getting a score here between 0 and 10. And 10 indicates that the material is exactly identical, and 0, and in fact in the range 0 to something like 3 or 4, means the material is completely different. In this sort of range here, in the 5 to 6, it means that it's similar, but there are critical differences. So these were 3 different batches of material that I was given once, and we tested all 3, and it was very clear that these 2 batches of material here were very similar, and this batch was a little bit different. So we entered these as reference material, and you can see when this is compared, it says that there are similarities, but it's not the same as these 2 batches here. It's a nylon material, this. If we look at the batch summary reports, here are the average scores, and you can see the 2 batches that are consistent score approximately 9, so they're well within the region that we would consider them similar. The batch that's different is about half that, so there's clearly big differences. If we look at the melting points, we can see that the batch that's different has a higher melting point, but the biggest differences occur with the glass transition. The glass transition for this batch is some 10 degrees lower than it is for the other 2. The end point is about the same. And this had become obvious why this is. What we can see, this is the test certificate. So, for example, if we've tested a batch of material, we can pass this on to the customer, showing how it meets all the properties that we would normally expect. Here we've got a comparison of grades. This is going into a little bit more detail on the being able to compare different grades of materials. So here along the top, I've actually got 5 different samples. I have a failed component, which was historic. It's from a few years ago. Bag 2 is a recycled material. Bag 6 is a recycled material. This yellow one, SPS, is actually this grade 12168. HDPE, and this light blue material, bag 99, is this grade X123. And what we see in this graph here, remember 10 means a material that's exactly the same. So the first big thing to see is the failed component scores very low. So the failed component was made from a batch of polyethylene that wasn't the same as any of the normal grades. Bag 2 is interesting, or perhaps we'll look at this one, yellow one first. This material, as you would expect, scores a very high score with itself because it is that material. Bag 2 is actually this same material, but it's been recycled, and it still scores an acceptable score to match it, so we could safely use that recycled material. But bag 6 is interesting because bag 6 actually is quite a low score, and this is meant to be this grade of material here. And finally, this light blue one, this is the other grade of material, so as you might expect, it's not coming out the same. What we can see, though, that's quite interesting is that here, again, the light blue material, it scores very well with itself because it is that material. But interestingly here, here's the other grade of material, and again, this doesn't match as we would expect, as does the recycler of the same. But interestingly, bag 6 is a high score. So what's actually happened here, somebody has mixed up the recycler, and although they thought it was this material here, it is actually, in fact, this material here. So this goes to show how very easy it is to check that you actually have got the right material by matching it to the grade. We have a camera option on the identiPol where we can actually see the plastic melt. So it will record one image every degree. So here we see the image actually at the melting point, and here we see the image some 15 degrees higher than the melting point. And interestingly, you can still see some of the original granule shape in there, even though the bulk of the material is melted. But this little image that's left on top hasn't quite gone, but by the time it's 15 degrees higher, most of it has gone. And that's just showing you the properties of this PET material. Here's the melt flow. This is only available for PP and PE, and it isn't an absolute measurement, so we have to calibrate the identiPol before we can use it. And we do that with known grades of material. And every time we run the test, we then get an indication of the melt flow index. So in summary, you can see the identiPol allows the testing of raw material and finished product. It's compact, lightweight and portable. You can run it with a laptop, and you just need to take the identiPol on the laptop. It requires no facilities other than mains electricity. It's simple to use, no plastics knowledge is required. All of those measurements are made completely automatically. We can do material identification. We can detect bad batches of material. Similarly, if a batch was contaminated, it would show as being different. We can do the grade comparison. And in addition to all of the features I've shown you today, there's comprehensive plotting packages of the raw thermal analysis data if you wish to get into that much detail. So I'd like to finish my presentation there. Thank you all for your attention, and I'd be happy to answer any questions or queries that you might have. I'll stop sharing my screen at this point, if I can. There we go. Right, there we go. Okay, right. Okay, do we have any questions?
First, thank you very much, John, for this presentation. It's very nice to see how you can use identiPol to identify, well, different sorts of materials. Well, there's one question that we had that has to do with is if it was possible to differentiate between different recycled materials.
Yes, I'll go back to the
Mhm.
slide that we were looking at not so long ago. So let's just bring that slide up again. Yes, so here you can see the slide we were just looking at before. There's actually two grades of.
Sorry, I'm not.
Oh, I'm not sharing the screen. Ah, yes, no. Well spotted. Yes, apologies. So let's just share the screen. Let's share the screen again. Okay, can you see the graph again?
Yeah.
There we go. Okay. Yes, so there are two grades of material here. This 12168 and X123, both grades of HDPE that are quite different from each other, because you can see when you test this blue material here against this reference set, it scores very low, showing that they're quite different. And similarly, when you test the yellow material against this one, again, it has a very low score. So we can immediately see how we can check the difference between two grades. And with these recycled ones, this is the recycled material compared to itself. And here, naturally, we get a high score for this bag 2 material, because this bag 2 material is HDPE and it is this grade here. Similarly, the yellow is the same grade, so again we get a high score. But this was very interesting that both the failed component, which clearly there's something wrong with this match, and here the bag 6, which was really interesting, because bag 6 was meant to be this grade here, the 12168. But in fact, it's very clear when we measure it against the X123, you can see that somebody's clearly got this bag of recycler mixed up. They've ended up with this grade of material here and thinking it was this one. But we've very easily been able to see whether that's the right material or not. And also, if you were buying in material from scrap, and if it was a significant deviation from what you would normally have, then again, you'd get a very low score when you tested this batch against what the material should be. So is that clear?
Yeah, I can see how you can differentiate in this case.
Yeah, and this is actually a very powerful feature, because even if you had a laboratory full of equipment, because we have a reference set of the materials that you're using in your factory, you will create a reference set. It takes about half a day to create a reference set, so it's not a big job. But once you have those reference sets, we can compare anything that we measure against those reference sets. And as I said, if you had a laboratory full of or a room full of proper research quality instrumentation, you'd have to do a lot of measurements to make sure that that material was what you thought it was. But because we already have a stored reference set, all we have to do is match that material to the reference set, and one simple test will tell us unambiguously that that's what the material is.
That's awesome, because it saves you time, it saves you money in determining if everything is what you expect to be.
Yeah, that's right.
Well, that's great. On my end, this is the question I had. I'm not sure. I'm going to speak in Spanish a bit. Pare, ¿tienes alguna otra pregunta? ¿Tienen las personas que están conectadas en español. ¿Tienen
Igual,
alguna pregunta para hacer? ¿Está todo
exacto, de todas
claro?
maneras.
¿Les gustaría preguntar algo adicional al señor John Duncan?
De acuerdo. Si alguien tiene alguna pregunta, inicialmente el tema de la medición del índice de fluidez eh, también se puede medir con el equipo identiPol. Si por favor nos puede dar un comentario de cuál sería la aplicación de la prueba del MEL Index utilizando el equipo identiPol. Muchas gracias.
La aplicación de la prueba en que...
El MEL Index.
Okay, Mr. John, so we have the question, what is the application of running the test of melt index? Could you please explain us a little bit?
Yes. We the machine is actually equipped with an automatic molding plunger. We record. You put a granule of material into the machine, and then it heats up, and it automatically presses that into the metal sample holder. And when it does that, we can actually record the data of how it squashes in, which of course depends on the viscosity of the material. And we have an algorithm that actually lets you compare the measurement we make with the melt flow index. Because it's a very different measurement from the melt flow index, we do have to calibrate the instrument with known MFI material. We have to do that first. But once it's calibrated with known MFI material, every time you run a test, it will give you an estimate of what the MFI value is. Now, it may not be 100% accurate. So, for example, if you were expecting a material to have, say, a melt flow index of 2, it might come up and say that it's 2.2 or 1.8, which probably is within the acceptable range. There's quite a bit of variation when you measure MFI anyway. But if it was the wrong material and say it had an MFI of 10, well, the identiPol would calculate a completely different answer. So instead of getting the 2 that we expected, you might get a value of 8 or 12. But clearly, it's not the value of 2 that you would expect. So it's only an indication of the melt flow, but it's sufficiently accurate to tell you if you've got a problem with the batch that you've just received.
Completely understood. Well, thank you very much. ¿Valdría la pena traducirla en español ya mismo?
Sí, por supuesto. Por
Ok.
supuesto.
Dice que la prueba del Melt Flow Index es una prueba que hace el identiPol. Esta se calcula pues con un algoritmo que ellos ya tienen, que se calcula cuando uno pone la muestra en la cajita del equipo. Cuando esta muestra se calienta y se derrite, pues esto tiene que ver con la viscosidad del material, y entonces le dice a la persona pues qué tanto pues cómo se derrite el material ante el calor que le pone la máquina. Dice que no es un resultado 100% pues seguro, pero que sí es una muy buena estimación, porque ellos calibran los equipos con base en materiales que ya se conocen, en materiales que ya están muy determinados cuál es el índice de melt, en el que se derrite el material. Por tanto, una nueva prueba, una nueva muestra puede estimarse cuál es su índice en el que se derrite, y así decir si es parecido a lo que ya conocía o no. Y entonces así se puede saber si el material está bien o mal.
De acuerdo, muchísimas gracias. La otra pregunta es, como para hacer un pequeño resumen en relación con el uso de lados. Y efectivamente se puede, digamos, como tener una aproximación al comportamiento real a partir de mezclas de materiales vírgenes y reciclados en el equipo de identiPol antes de, obviamente, utilizar estos materiales
En producción.
en el proceso de inyección o de extrusión o en el procesamiento posterior.
Pero esto es, lo que te refieres a comportamiento real es...
Sí, o sea, ¿qué tanta analogía hay entre el comportamiento del equipo de identiPol cuando se usan mezclas de materiales en comparación con cuando se usan en el proceso productivo?
Ok, ok, eso lo podemos montar. Mr. John, thank you very much. We had another question. It
No,
has
it's
to
my
do
pleasure.
with how closely related are the results that we find in the identipol and what we expect to have in the production environment.
How repeatable are all of the results? Is that what you're saying?
Yeah, basically.
Okay. The automatically determined melting points are typically within a degree of what you'd expect to measure on a DSC. The standard test you do on a DSC at 10 degrees a minute and gives a melting point. We would expect to come within a degree of that, and that should repeat within that sort of accuracy. The end point is our own parameter. That's where you can no longer tell the difference between the plastic and the metal holder. The glass transitions, they're always a little bit different depending on how you measure them. But again, the repeatability should be within a degree or two for that. The MFI will be, it's about the repeatability that you normally get from an MFI test. And the main parameter that we use for determining whether the material is actually the same or not is this chemometrics value of where we automatically compare the difference between the tan delta curves for a material, which is a very good fingerprint for the material, and that's quite sensitive. But if the answer falls between 7 to 10, that means that it's so similar it's perfectly safe to use. If it drops outside of that range, usually what you find most often is that it's the same material, but there's a contaminant in there, especially if it's a recycler. So, for example, if it's recycled polypropylene, what you often find is the polypropylene part is okay, but you've actually got a bit of mixed polyethylene in there. And if it's just a couple of percent, you can probably accept it. Anything less than that, we probably wouldn't see it. But if it was about 10%, then obviously it's going to affect the properties of that material, and it may well not be acceptable. So does that answer that question?
Yes. So just let me confirm the ranges. So if it's more than 10% different, then you would expect not to use that, or at least you know the properties.
Yeah, it would depend. It would depend what you're doing. If you were making a high precision nylon bearing, you would probably want the material to be, well within spec. If you're making something that's much less critical, like some sort of polypropylene tray that doesn't experience significant loading, then obviously you can tolerate a wider range of variation in the material. And the identipol will actually give you a clue as to how much the material is varying. And then if it is, as I say, if it's a high precision part, you would want a good result before you used it for moulding. If it's something that isn't very critical, then you could try it out and see whether it moulded correctly. And then if you add that material into the reference set, the reference sets are self-scaling. So that, in other words, if the material that you use is quite variable, then all of the variable material will automatically fall within the acceptable range. If, on the other hand, the material is very precise, then even a very small difference will show a very big difference in our quality index score. So you don't have to worry about that. That scaling is completely automatic.
Okay, okay, I understand. Just let me tell a bit in Spanish.
Yes, of course.
Bueno, dice que para las mediciones que el equipo realiza en varios de los de los índices que analiza, son en una diferencia de un grado de lo que uno puede esperar de estos materiales en producción, con lo cual pues son unos resultados bastante cercanos a lo que la gente puede esperar en producción, y se unen a las pruebas pues estándar que se realizan en la industria. También para materiales reciclados, hay que tener en cuenta que los materiales reciclados pues sí tienen o pueden tener parte de otros materiales. En este caso, el equipo analiza, por ejemplo, el Flow Index u otros índices y mostrará una diferencia. Si es un material reciclado que está muy puro, pues entonces la variación no será mucha, pero normalmente se puede esperar que hayan otros materiales, con lo cual la variación puede llegar a ser hasta de un 10% o más de diferencia. Con lo cual, por ejemplo, si uno necesita hacer o tiene una aplicación con un material que necesita que sea muy puro, o cumplir dentro de una especificación o una norma muy clara, muy sólida, pues esperará que el material que use sea lo más puro posible, por lo cual pues con el tema del reciclado se puede complicar en cierto punto, aunque el equipo pues da la prueba y esta es a la consideración de la persona, dependiendo de la aplicación que tenga. Uno de los ejemplos que da el señor John es con el tema del nylon. Si necesita que sea un nylon muy con unas cuestiones muy precisas, pues buscará que la diferencia sea menor a un 10%. Pero si es una cuestión allí para cargar como una bandejita o algo así que no va a tener pues gran peso, no va a tener gran esfuerzo, pues entonces sí se puede usar y se admiten ya otros valores. Todo depende de la aplicación que se le esté dando al material reciclado que se quiera tener allí, por lo cual pues varía de cada, pues en cada caso. Y en ese sentido me surge la duda a mí si para las personas que están escuchando sería útil tener una especie de asesoría de cuál sería el mejor rango, porque el señor John pues también es experto en todo esto. Voy a preguntarle igualmente. Mr. John, one question that I have after going through this part in Spanish, and it is, what if one of our clients need some kind of some kind of help in one of these parts. So for example, in determining what is the best range of difference in which their material should fall, or for the application they have, because maybe, well, this might be new to some of them, or maybe this is something that you would have more experience with. If one of them has any kind of doubt, or maybe just a question, would they be able to ask you, or to ask you through us?
Yes, it's obviously it depends very much on the kind of component that they're making, like I was saying earlier. Some mouldings will be very uncritical. You know, if you're making fairly large components, something like a bucket or something, then the material properties are not really too critical, and a wide range of material would satisfy it. On the other hand, if you're making something like a car bumper or one of these drainage crates that's actually loaded, then the mechanical properties of that are quite significant, and I don't think that you wouldn't really want any significant variation at all with a component like that. So you'd always want those batches to have a high score in comparison to the known virgin material.
Okay, I understand. And
Yeah.
yep, I understand.
The only way that you can really put numbers to it is, you know, take something, for example, like a car bumper. If somebody was making a car bumper, and if they have a supply of material that they know isn't as good, the identiPol would show it as not being up to the standard it normally would be. And the only thing that you could do would be an impact test would be very critical to the performance of a car bumper. And you could carry out an impact test to see whether that material actually was satisfactory or not. If it was, then by including it in the reference set, you'd automatically allow similar batches to be included. If it turned out that that wasn't satisfactory, then the identiPol is already identifying material which would lead to failures in service.
Okay, I understand. Okay, so I'll translate that.
Okay.
Bueno, para la parte de la aplicación y cuáles son las diferencias que se pueden encontrar con identiPol. Todo depende de la aplicación, como dice el señor John, y depende mucho, por ejemplo, si uno está haciendo un tarro, una botella, pues puede darse ciertas exenciones, no tiene que ser perfecto el material, pero hay otras aplicaciones donde el material tiene que tener cierto esfuerzo y por tanto las propiedades mecánicas tienen que mantenerse estables. Y la idea es que en el proceso, pues uno siempre va a querer que las pruebas mecánicas se mantengan iguales o para cumplir los estándares. Por lo cual, por ejemplo, en el caso que pone el señor John, en el caso de un bumper de un carro, tendría que cumplir básicamente como casi siempre las mismas pruebas para que cumpla con el estándar, porque allí un impacto en el bumper, por ejemplo, puede ser un tema muy crítico. Entonces, en cuanto a ese material, del bumper, por ejemplo, el identiPol, si uno ya tiene la referencia, pues él le diría, esta nueva prueba, esta nueva batch de material, este nuevo recurso allí que consiguió la empresa de material, cumple o no cumple con el estándar que uno quiere, con la referencia que le dio inicialmente. Pero también dice que lo que uno puede hacer es, si está evaluando un material que sea un poco menos, pues de un poco menos calidad del que uno ya conoce, lo que puede hacer es finalmente, bueno, hacer el bumper y hacer la prueba de si eso finalmente el impacto está bien o mal, y si cambia mucho. Si no cambia mucho, Entonces lo que dice el señor John es que se podría añadir en la máquina como una referencia nueva, y entonces el identiPol ahora tendrá también esa referencia para validar y esperar que los siguientes envíos de material que le hagan a uno a su empresa pues cumplan con eso. Pero sí depende mucho de cada aplicación, por lo cual pues en cada caso eh, tendremos diferencias. Algunas personas aquí hacen estas botellas, envases, tarros, complementos plásticos para oficina, cualquier cosa. Entonces depende mucho de la calidad y de la resistencia que se necesite que tenga el material. That's it, Mr. John. That was the question that I had. Maybe let me check if we have any further questions from the public or from my father. Padre, ¿tenemos alguna otra pregunta del público? ¿Tenemos alguna otra pregunta de tu parte?
Hola, buenos días.
Buenos días.
Buenos días. Mi nombre es Juan Carlos Tirado, soy de la empresa FlexiPlus. Yo tenía una consulta para John relacionada con el análisis sobre master batch pigmentados. ¿Tiene algún procedimiento, protocolo particular para esto? ¿El equipo nos funciona muy bien o cómo sería el procedimiento?
Master batch, ¿me repites, por favor?
Master batch pigmentados, para pigmentos, básicamente.
Okay. So, Mr. John, we had a question from one company, and it is about pigmented master batch. Does the identiPol work with that? Do you have any kind of experience with that, with the identiPol?
Sorry, I couldn't hear all of that. Could you say again, please?
Sure. It is pigmented master batch.
Oh, yes, yeah.
Is the device ready to work with that? Does it work well? Do you have experience with that?
Yeah, we have tested master batch materials, and normally they just tend to be a lower molecular weight version of the polymer that you're going to mix them with. So, for example, if you have a red pigment for polyethylene, it's usually a lower molecular weight polyethylene mixed with the red pigment, and we are able to measure that just as if it was a polyethylene material. We did take some samples from a master batch stand at an exhibition once. They were actually our neighbours at the exhibition, and they were quite surprised because they thought the material in this certain master batch was actually a polypropylene, and we identified it as a polyethylene instead. So that was quite a surprise to them. But yes, typically the master batches are just usually they're either a very similar polymer or often a slightly lower molecular weight version, so it might flow a little bit better.
Okay. Sí, correcto, Juan Carlos. Tienen experiencia con esto, con el master batch pigmentado. Dice que normalmente son pues como el mismo material, pero con un poco de peso molecular menos, que lo han probado, lo probaron incluso en una exhibición, y descubrieron que el material final que la persona tenía allí, ellos creyeron que era un material, resultó siendo otro, y pues fue una gran sorpresa para ellos porque no lo podían, no lo sabían, no lo habían determinado. Entonces sí, se puede usar, y el equipo pues funciona con polietileno.
Una consulta, sí, gracias, está entendido. Una consulta adicional a este tema del master batch. ¿Es posible detectar aquí la presencia de cargas minerales como carbonatos, que puede ser también una diferenciación entre un master batch y otro con este equipo?
Mr. John, is it possible to determine the presence of other Yeah, of
materials.
other materials in the component in the master batch, for example,
Well,
carbonate.
the identiPol will only detect plastics. So this is actually quite an advantage, because if, for example, there's a lot of filler in there, a spectroscopic technique may fail to identify the material, but other than in the change in stiffness, we don't really see the filler material. We'll still be able to detect the melting point and things like that. So if, for example, you have, say, a polypropylene material that's contaminated with HDPE, then we would see two melting points. You'd see the melting point of the polypropylene
Mm-hmm.
and the melting point of the polyethylene contaminant. So you would know that there was something there that shouldn't be there.
Okay.
Okay.
Oh,
Okay. Thank you.
okay.
Pleasure.
Is there any other question, maybe? Does that answer your question, Juan Carlos?
Yes, I understand. Thank you.
Okay, thank you.
Hola, Juan.
Sí.
Juan, una pregunta. Para nylon, específicamente, normalmente hemos hablado de polietileno, polipropileno, pero el nylon también es plenamente aplicable en el uso de identiPol, ¿cierto?
Sí, él había puesto un ejemplo con nylon. Y sí. Pero si quieres le pregunto un poco más sobre qué experiencia tiene también.
¿Alguna característica especial del nylon 6.6, nylon 6 o si todas las posibilidades?
Mr. John, is identiPol able to work with different types of nylon?
Yes, it actually works very well with nylon. We're easily able to distinguish between nylon 6, and I think 45 as well. So we can easily distinguish between three types of nylon.
Okay. 6C?
Yeah,
6,
let me just check which
and 45.
I know it's 6 and 6. Let me just check. Yes,
Pero,
it's 46. 6 and 46.
6, and 46.
They're the more common grades. You sometimes see 12. I don't know that I've really tested 12.
But if it's not that common.
No. 6 and 6 and 46. 46 is more of a high performance engineering grade, but they tend to be the ones I've come across.
Okay. Okay. And in England, do you have any clients that have used this?
What, with nylon?
Or around the world, maybe an example you can give us.
Yeah. Most of the clients in recent years, a lot of people are using PP and polyethylene. We have got, there's a few Italian customers using PVC and nylon, and we have some people using ABS and polystyrene. But I would say the majority of customers, particularly in the last few years, have all been polyethylene and polypropylene, and not surprising because most of the volume material is those two materials.
Sure.
There's, I think we must have about 55 instruments out in the field now.
Great.
And they're mostly, because of our sales activity, they're mostly in the UK and Italy.
Okay, I understand. Just let me translate that little part for the record.
Yeah.
For the people we have. So, yes, sí, identiPol se puede usar con nylon sin ningún problema. el señor John ha tenido experiencia con pues diferentes tipos de nylon. Menciona el nylon 6, el nylon 6.6, el nylon 4.6. El último dice que es un tipo de nylon pues muy usado en ingeniería, en aplicaciones como distintas, y que hay un tipo de nylon 12, él lo menciona, pero que ese no es muy común. La mayoría también de los equipos de identiPol, que son unos más de 50, 55 alrededor del mundo, están pues en clientes que ellos tienen allá en Inglaterra, de donde vienen, y en Italia. En Italia también hay otras personas usando nylon con PVC, pero pues lo más común, según lo que reporta el señor John, es en la parte de polietileno. ¿Está bien? Tienes el micrófono apagado. Padre, tienes el micrófono apagado.
Si tienen alguna inquietud, algún comentario adicional, es que lo hagan llegar al correo guarin@gpasas.com para atender sus inquietudes. Igualmente, si tienen posteriormente la posibilidad de concertar una reunión virtual y poder atender las inquietudes, un caso específico, y como siempre pues estamos a sus órdenes. Muchas gracias.
Bueno, creo que eso es pues todo.
Sí, perfecto, gracias.
Estoy añadiendo acá sobre el video que va a quedar guardado la dirección de correo electrónico donde se pueden contactar, por favor, para tener más información sobre el identiPol, sobre nuestra empresa, y darles muchas gracias por la asistencia. El correo, lo repito, es guarin, GUARIN @gpasas.com. Es también el sitio de nuestra tienda virtual donde tenemos expuestos diferentes otros equipos, y les agradecemos mucho por su asistencia y por sus preguntas. Muchas gracias. Gracias, Juan Carlos, también por la asistencia.
Gracias también.
Perfecto, muchas gracias, señor Juan Carlos, muchas gracias a todos. Gracias también al señor Duncan y a Sara. Gracias por esta ocasión de conocer un poco más sobre el equipo de identiPol. Muchas gracias.
Thank you very much, Mr. John. Thank you very much, Sarah.
That's a pleasure, and thank you all for listening, and thank you for doing the translating for me.
It's okay. Thank you very much, Mr. John.
Okay.
Thank you for your
I
time.
wish you all a very pleasant day.
For you too. Have a great day.
Thank you. Goodbye.
Thank you. Goodbye.
Goodbye.
Bye-bye.